We're going to be looking at solving linear systems using formulas. So here are two linear systems, and they're written a little differently. And what we're going to just quickly show you is on the other page I've typed them in, and their format is a little different, but essentially their point of intersection is negative 0.5, negative 0.5, or negative a half, and negative a half. What we're going to do is show that we know that we can use substitution elimination. We can also use these formulas, okay, assuming we fix up our coefficients and constants with the right variables to solve the points of intersection. So these two formulas can essentially solve it as long as we put our equations of a line in a specific format. So in both of the formats, we need them to be equal to 0. So we'll move all terms onto one side of the equation. In this one, I'll move the 4 over so it's quickly set equal to 0. So we have 5x plus 3y plus 4 equals 0. In our other one, we have the 8y on this side. So I'm going to move it over to the right, and this will say 0 is equal to 2x. And I'm just going to put it in the same order, negative 8y minus 3. So now that I've done this, and we kind of want to set ours up so we have our x variable, then our y variable, then our constant, and then the same in our second equation. We have to be able to tell you what coefficient is what. So our a coefficient is the 5, our b coefficient is 3, and our c coefficient is, our c constant is positive 4. In our other equation, our d coefficient is 2, our e coefficient, to get another color out here, is negative 8, and our our f constant is negative 3. So now that we have these 6 numbers, we can essentially plug them into these formulas. Okay. So let's start with our x value here. I'll do it on the left. Our x is going to be equal to our e value, which was negative 8. Okay, so let's get our e value. Let's see it here. There we go. Good. So we have negative 8 times our c value. Okay, and our c value was positive 4. And then we're going to take those numbers and subtract our b value, which is positive 3, times our f value, which is negative 3. Okay, and all of that will be divided by, we need our b value, which is 3, our d value, which is positive 2, subtract our e value. There's quite a bit of organization involved here, which is again negative 8, times our a value, which was 5. Okay, so we have all 6 of our terms in here, and we're essentially just going to use some BEDMAS here. Negative 8 times 4 gives us negative 32. Okay, and 3 times negative 3 is negative 9, so we're going to be subtracting negative 9. All of that will be divided by 3 times 2, which is our 6. We're going to be subtracting 8 times 5. It's negative 40. Okay. We're going to simplify our terms. This will become negative 32 plus 9. We have our two negatives together. You can simplify into an addition question. And same idea on the bottom. It'll be 6 plus 40. So on top, we'll end up with 23 over 46. And again, this is, negative 23 over 46. And if we divide the top by 23, we have our negative 1. And if we divide the bottom by 23, it's 2. So our x value is negative a half, which is exactly what we found on our graph. Okay, let's do the same thing with our y value, see if this formula works. Our y value is our d, okay, we knew our d is 2, that's why I color coded so I don't have to jump up as much, times our c was 4, subtracted by our a value, which was 5, times our f value, which was negative 3, and all of that will be divided by, okay, this, our a value again, which is 5, times our e value, which was negative 8, subtracted by our d value, which was 2, and our b value, which was 3. So again, it's just BEDMAS from here once we've organized everything. 2 times 4 will give us 8. subtract 5 times negative 3 is negative 15 divided by negative 5 times 8 is negative 40, subtract our 6. Very similar to what we had before on the bottom. On top is going to be 8 plus 15, and I'll simplify the bottom, might as well. And this will become negative 46. 8 plus 14 is 23 divided by negative 46. And again, we know that this already simplifies into negative 1 over 2, which is exactly what we found when we graphed it. We graphed our two equations, negative 5 and negative 5. So if you're not very strong with substitution and elimination, the process you find very confusing, if you can memorize, which personally I always find harder, but if you can memorize these two formulas and you know how to set them up, you can essentially solve substitution or a linear system, using formulas.